In this lesson, you're going to learn how to solve a compound linear inequality, and you're going to graph the solutions. So let's look at number one. So number one, we have 3x plus 4 is greater than or equal to negative 8, and that word and is important, and 4x minus 3 is less than or equal to 13. So notice I have two linear inequalities joined by the word and. All right, so whenever you have two linear inequalities joined by the word and or the word or, this is going to be called a compound inequality. All right, so we're solving this compound inequality because we have two inequalities joined by the word and it could have been the word or. But the word and the word or mean different things. Okay, so basically we have to solve each inequality individually first. Okay, but remember we're looking at the word and that's going to be important. All right, so to solve this inequality, so it's going to be the work. So to solve this inequality, I'm going to go ahead and subtract 4 from both sides and then combine like terms. So this is 0 here. So I get 3x is greater than or equal to a negative 8 and a negative 4 is a negative 12. And to get x by itself, I'm going to go ahead and divide both sides by 3. So dividing both sides by 3, 3 divided by 3 is 1. 1 times x is x. So x is greater than or equal to, and then negative 12 divided by 3 is a negative 4. Now what I found is this. You see where it says that x is greater than or equal to negative 4? That means that the solutions to this inequality right here, the one I'm circling, is any number greater than or equal to negative 4. So if I substitute any number greater than or equal to negative 4, it's going to make this left-hand side greater than or equal to a negative 8. For example, do y'all agree that 0 is greater than or equal to negative 4? So if I substitute 0 in here, 3 times 0 is 0. 0 plus 4 is 4, and 4 is greater than or equal to negative 8. If I substitute negative 1, because negative 1 is greater than or equal to negative 4, look what happens. What's 3 times negative 1? 3 times negative 1 is a negative 3. Negative 3 plus 4 is a positive 1, and 1 is greater than or equal to negative 8. All right, so any number in here is a solution to this one. All right, now let's go ahead and solve this one. So for this one, I'm going to add 3 to both sides, and so I get 4x is less than or equal to, these add up to be 0. 13 plus 3 is 16. To get x by itself, the coefficient of x is 4, so remember this reads 4 times x. So the opposite of multiplication is division, so I'm going to divide both sides by 4. When I do that, 4 divided by 4 is 1, 1 times x is less than or equal to, and then 16 divided by 4 is 4. Okay, but remember, I have the word and, right? So make sure you write that down, the word and. Okay, and means intersection. And means intersection. So what that means is that the solution to this compound inequality, has to be the solutions here and the solutions here that they have in common. Okay? So the solutions to the compound inequality has to be the solutions that these two have in common. So the intersection. All right, so here's how you're gonna get your final graph. All right, the way to do this is to graph each one individually. So here's the graph, x is greater than or equal to negative 4. All right, so negative 4, let's say this is negative 4. Since it's greater than or equal to, you see that equal sign? We're going to put a closed circle, and I'm going to shade in every number to the right because it says that x has to be greater than or equal to negative 4. Now let's do this one. So let's graph x is less than or equal to 4. All right, now be careful. Always put, when you put the numbers, put them in relation to each other. So you see this is a positive 4, this is a negative 4. So make sure you put positive 4 to the right of negative 4. So here's positive 4. So my solution would be any number less than or equal to 4, right? And so I put a closed circle since there's an equal symbol. I'm going to shade in every number to the left. All right, now the solution to the original problem, 3x plus 4 is greater than or equal to negative 8, and 4x minus 3 is less than or equal to 13, is what these two have in common. So if you look at what they have in common, where they overlap, always shade in what they overlap. So they overlap from -4 to +4. So on the number line, you're going to put -4, +4, and they're both closed circles, right? So closed circle, and shade in every number between them. So every real number that's shaded is a solution to this original inequality. So it's going to satisfy this and this at the same time. So notice 5 is not shaded, right? 5 is not shaded. Even though 5 is greater than or equal to -4, the reason it's not shaded is because 5 is not less than or equal to 4. So your solution to the original has to satisfy this and this at the same time. So that's why you look at the intersection. All right? So if you pick any number that's in here and substitute in both of these are going to be true. If you pick any number on the outside, both of those are not going to be true at the same time. For example, remember we said 5, right? 5. So let's check this one. 3 times 5 is 15. 15 plus 4 is 19. Is 19 greater than or equal to -8? Yes. Now let's check this one. 4 times 5 is 20. 20 minus 3 is 17. Is 17 less than or equal to 13? The answer is no. All right? So that's why 5 is not a solution. But any number in here is. So let's say you pick 2. 2 is in here, right? Let's pick 2. Let's see what happens. 3 times 2 is 6. 6 plus 4 is 10. Is 10 greater than or equal to -8? Yes. Let's check this one. 4 times 2 is 8. 8 minus 3 is 5. Is 5 less than or equal to 13? Yes. So that's why 2 is a solution, because 2 satisfies this and this at the same time. All right? So that's number 1. So that's how you solve an AND inequality, an AND compound statement. Make sure you look for the intersection. So graph each one individually and see where they overlap. And then that would be your solution. So let's look at another. So let's look at number 2. So number 2, let's suppose we had this problem. Okay, number 2. All right, number 2. Let's suppose we had -11 is less than 3x plus 4 is less than or equal to 16. All right, now notice it looks different than what we talked about here, where a compound inequality is, we said it was two linear inequalities joined by the word and or the word or, right? But you don't see that written like this. You see it looks different. But this is still a compound inequality. This is still a compound inequality. Now, what I want you to notice is that I can write this compound inequality as an and statement. So whenever it looks like this, what you're saying is this: -11 is less than 3x plus 4. And at the same time, 3x plus 4 has to be less than or equal to 16. That's what this means. So every time something's written like this, that's an and compound statement. So basically you're saying -11 is less than 3x plus 4, and 3x plus 4 has to be less than or equal to 16. So this means an and compound statement. And we're going to do this just like we did this. Okay, so let's go ahead and do that. So just remember, because you're going to see something like this on a test or for a final exam, and that's going to be needed for some future concept. So remember, this compound statement that looks like this is an and statement. So -11 is less than 3x plus 4, which is what you see here. And at the same time, 3x plus 4 has to be less than or equal to 16. All right, so let's solve each one individually. Let's get x by itself over here. So I'm going to subtract 4 from both sides. And so a -11 and a -4 is a -15 is less than, this is 0, 3x. To get x by itself, I'm going to divide both sides by 3. So -15 divided by 3 is a -5, and that's less than 1. 3 divided by 3 is 1. 1 times x is x. Okay, so remember, this right here is the solution to this inequality right here. Only this one, not the original, just this one. Now remember, another way to write this, and you saw this in a previous lesson, so -5 is less than x means the same thing as x is greater than negative 5. Those two mean the same thing, so just writing it backwards. X is greater than negative 5. Negative 5 less than x means x is greater than negative 5. Okay? All right, let's do this one. Let's subtract 4 from both sides. And so the 4's have to be 0. So I get 3x is less than or equal to 16 minus 4 is 12. To get x by itself, we're going to divide both sides by 3. And so I get x is less than or equal to 4. All right, now remember, that's an and statement, right? That's an and statement. So what that means is this. I'm going to graph each one individually. So graph each graph individually, and then we'll talk about the word and. All right, so x is greater than negative 5. This is the graph. So let's say this is negative 5. There's no equal sign, so we're going to put an open circle going to the right, as it says greater than. X is less than or equal to 4. Let's look at that one. X is less than or equal to 4. So make sure you put 4 on the correct side. So if this is negative 5, then 4 has to be on the right-hand side, right? And then closed circle because of the equal sign, and then less than going to the left. Now that's an and statement. So remember, and statement means intersection. So where do the two graphs overlap? So they overlap from negative 5 to 4. So that means that the solution to this compound inequality here would be solutions that these two inequalities have in common. And so you would say this: the solution to negative 11 is less than 3x plus 4 is less than or equal to 16 is, and then if you graph it, you're going to say negative 5 with an open circle to 4 with a closed circle. So negative 5, 4, open circle, closed circle, and then shading it in. Okay? All right, so that's the graph. That's the solution. So the solutions to this inequality would be any real number that's between negative 5 and 4. So for example, you see negative 1 is here, right? Negative 1 is shaded. So let's see why negative 1 is shaded. What's 3 times negative 1? Well, 3 times negative 1 is a negative 3. Negative 3 plus 4 is 1, right? So remember, that's 1. So is negative 11 less than 1? Yes. And is 1 less than or equal to 16? The answer is yes. Negative 8 is not shaded. So let's see why negative 8 is not shaded. 3 times negative 8 is a negative 24. Negative 24 plus 4 is a negative 20. Is negative 11 less than negative 20? The answer is no. Remember, negative 11 is greater than negative 20. Even though negative 20 is less than or equal to 16, the problem is negative 11 is not less than negative 20. So that's why it's not shaded. Okay? All right, so that is number 2. Now I want to show you something. You see how it's written like this? So you could have, instead of breaking it down as an and statement, you could have done this. Let me show you. So negative 11 is less than 3x plus 4 is less than or equal to 16. So we have this compound inequality. We know it's an and statement. But when it's written like this, I can easily get x by itself. And so to get x by itself in the middle, all I've got to do is subtract 4 from all parts, just like this. Remember, there are 3 parts: 1, 2, 3. A left, a middle, and a right. So you're going to subtract you're going to subtract 4 from all 3. So I'm trying to get x by itself. So if you were to cover this up and you were to solve this simple linear inequality, that's what you would have done, right? You would have subtracted 4 from both sides. Well, you have 3 parts here, so subtract 4 from all parts. Negative 11 and a negative 4 is a negative 15. It's less than, this is 0. So you get 3x is less than or equal to, and then 16 minus 4 is 12. To get x by itself, remember trying to get x by itself, where now you're multiplying by 3. The opposite is to divide all parts by 3. And so negative 15 divided by 3 is negative 5. Is less than 3 divided by 3 is 1. 1 times x is x. Is less than or equal to, and then 12 divided by 3 is 4. And so notice, see this right here? You see this right here, right? So your solution is between negative 5 and 4. That's what you had, right? So notice, see how all this work you had to do? When you do it this way, it's a lot quicker. But it's important to understand that that's an and statement. You're really looking for the intersection. So So this right here gives you the intersection of this inequality and this inequality. So that's what you found. Okay? And so basically the solution, you're going to say the solution graph, when graphing the solutions, you're going to say -5, 4, open circle, close circle, and then shade in everything between. And that's the same graph you had here. Okay? All right, so that was number 2. Now let's look at number 3. So number 3, now remember the first 2 dealt with an AND statement. So now we're going to look at an OR statement. What do we mean by an OR statement? All right, well, you looked at OR statements before. There was a previous lesson where you had an OR statement. So let's look at this one. So remember, an OR statement means the union. An AND statement means intersection. OR statement means the union. So let's look at this one. We have 4x minus 2 is greater than or equal to 6, or, notice or, 3x minus 4 is less than -13. All right, so I have this compound inequality with the word or this time. So I want you to remember, based on what you learned in the previous objective, that the or here means a union. So meaning that the solutions to the compound inequality will be any number that satisfies this, and also any number that satisfies this. So it has to satisfy at least this one or this one. Okay? So the solutions here is the solution to this compound. The solutions here is the solution to this compound. Okay? All right, so we're going to do the same thing. We're going to solve each one individually. So let me go ahead and rewrite this over. And let's do the process. So let's solve each compound, each inequality individually. So to get x by itself, I'm going to go ahead and add 2 to both sides. So I get 4x is greater than or equal to, and then 6 plus 2 is 8. And then divide both sides by 4. I get x is greater than or equal to 2. So notice what I found is that the solution here is the solution to this inequality. All right, but at the same time, I know this, right? That's an OR statement. So if this is the solution to this, then it's going to be the solution to the whole thing. Because remember, an OR means that the solution has to satisfy either this one or this one. It doesn't have to be both. And means it has to satisfy both. And OR means it just has to satisfy at least one of them. So this right here is a solution to the original statement. I couldn't do that here, right? I couldn't do that here. I couldn't say this is a solution to the original because that's an AND statement. So I had to look at the intersection. So all I could say is that this is a solution to this only. And then this is a solution to this only. And then to find where the two intersect, I had to graph each one individually and see where they overlap. So that's AND, that's OR. All right. So far I found part of my solution. So part of my solution would be any real number that's greater than or equal to 2. All right. Now let's solve this one, because this is also going to be a solution to the compound inequality. So I'm going to add 4 to both sides. So I get 3x is less than -13 plus 4 is a -9. Divide both sides by 3. And then 3 divided by 3 is 1. 1 times x is x. I get x is less than -9 divided by 3 is a -3. All right. Now, remember this is an R, right? So just like we did in number 1 and number 2, we're going to graph each one individually just to show you what we're looking at. So here's the graph of x greater than or equal to 2. So here's 2 greater than or equal to, shaded, going to the right. Closed circle going to the right. This one, x is less than -3. Make sure you put -3 in correct relation to where 2 is. So -3 is to the left, right? Open circle going to the left. All right, now remember, that's an OR statement. So an OR statement is different from an AND statement. An AND statement, you look for the intersection. An OR statement just means this. What's shaded here and what's shaded here is a solution to the original. So the solution to the original is any number here or any number here. And so basically you're just going to merge the two. You're going to put the two together. So you're going to say the solutions to this compound inequality, 4x minus 2 is greater than or equal to 6, are 3x minus 4 is less than negative 13 is, on one number line, you're going to say, remember, negative 3 comes before 2. So here's negative 3, here's 2. You're going to put an open circle in negative 3 going to the left. Make sure you draw your arrow. Make sure you shade it in. Make sure this looks like an open circle. You can put a closed circle on positive 2 and then going to the right. And there's your solution. So notice this R statement right here. You had two sets of graphs, let's say. You had the graph, part of the graph going here, and you had part of the graph going here. All right. Now, just to remind you, and you didn't have to do this here, but if I asked you to write this in interval notation, and you had interval notation before, interval notation. So remember, with interval notation, you go from left to right. So remember, this is pointing towards that idea of negative infinity. So you're going to say negative infinity in parentheses all the way to negative 3. Since there's an open circle, you're going to put a parentheses. Union. So remember, R means union, right? You see the symbol for union, that U, the symbol for union. Union, now this is a closed circle, so you need a bracket, 2, comma, and then this is pointing towards the idea of infinity. So you go infinity. Now remember, negative infinity, infinity, always parentheses with them. Always use parentheses with them. So there's that interval notation right there. If you wanted to look at interval notation with number 1, let's do that. Interval notation. Now they didn't ask you to do that, but if they did, you put bracket negative 4. See, and both of those are closed circles right here, 4 and negative 4. So bracket negative 4, comma 4 bracket. Okay? All right, so that's number 3. Let's look at number 4. So in number 4, we have another OR statement in number 4. So let's say we had this OR statement. 4x minus 6 is less than negative 18, or 4x minus 2 is greater than 18. So let's say we have that. All right. So remember, in OR statements, that's a union, correct? That's union. All right, so let's go ahead. I'm going to go ahead and rewrite this over. Same thing here. All right, let's solve each individual. Now remember, this is an OR statement, so that means that any solution here is a solution to the compound statement. Any solution to this one is a solution to this compound statement. All right, so let's go ahead and add 6 to both sides. So I get 4x is less than negative 18 plus 6 is a negative 12. Dividing both sides by 4, and then reducing. 4 divided by 4 is 1. 1 times x is x. I get x is less than negative 3, right? So x is less than negative 3. So any number less than negative 3, any real number less than negative 3 is a solution to this original compound inequality, because of that OR statement. So x is less than negative 3 is a solution to this one. So since the solution to this is going to be a solution to the original, because an OR statement means that the solution to this R compound inequality has to satisfy either one, either this one or this one. Over here, if I add 2 to both sides, I get 4x is greater than 20, and dividing both sides by 4 to get x by itself, and then reducing. 4 divided by 4 is 1. 1 times x is x. I get x is greater than 5. All right, so remember this is an R, right? That's an R. So if I look at each one individually, so here's a solution, here's a graph of x is less than negative 3. Let's say right here, open circle going to the left. And here's the graph of x is greater than 5. Make sure you put in the right spot. 5 is to the right of negative 3. Open circle going to the right. And remember, that's an OR statement. So anything shaded here is a solution to the original, and anything shaded here is a solution to the original as well. So we're going to merge the two. So the solutions, 2, 4x minus 6 is less than negative 18, or 4x minus 2 is greater than 18 is, and you're going to put on one number line. So here's negative 3, open circle going to the left, and then 5, open circle going to the right, and there's your answer. There's the graph. All right. Now they wanted to, so remember this is the graph. So they wanted to write the solutions in interval notation. Remember, you go from left to right. You go from smallest to largest. So remember, this arrow is pointing towards negative infinity. So you can say parentheses, negative infinity, comma, -3. Since that's an open circle, use parentheses. Union, remember R means union. Union, open circle. So parentheses 5 to infinity. All right, and remember, infinity, negative infinity, always use the parentheses regardless of if you see an equal sign or not. All right, so that's number 4. All right, let's look at number 5. So number 5, all right, so number 5, we have 3x plus 1 is less than -10. R, so it's another R compound statement. So remember, R means union, right? R means union. And then 2x minus 5 is greater than or equal to -1. So the solutions to this, to either one of these, either this or this, is the solution to the compound inequality. So let's solve each one individually. So I have 3x plus 1 is less than -10. And then 2x minus 5 is greater than or equal to -1. So I'm just rewriting it over. So remember, that's an R statement. So I'm going to subtract 1 from both sides, and then when I combine like terms, this is 0, I get 3x is less than, let's go ahead and make, well, that's fine. It's going to be -11. So I'm going to end up with a fraction, but that's okay. I did not mean to put a fraction here. I'm just going to leave it like it is. And then dividing both sides by 3, I get x is less than -11/3. All right. Now, if I want to rewrite this as a mixed number, I could. So I could say Rx is less than 3 divided to 11 is 3, right? So I get -3 and 2/3. 3 times 3 is 9. 9 plus 2 is 11. All right. So this and this same thing. I did not mean to end up with a fraction, but since I wrote it like this, I'll just leave it. Over here, I'm going to add 5 to both sides. And so I get 2x is greater than or equal to -1 plus 5 is 4. Divide both sides by 2, and then reduce. I get x is greater than or equal to 4 divided by 2 is 2. All right, remember that's an R, correct? That's an R statement. So if we look at each one individually, all right, so this would be x is less than -3 and 2/3. So let's say this is -3 and 2/3 right here. There's no equal sign, so I'm using an open circle going to the left, okay, because it says less than. Over here, x is greater than or equal to 2. Make sure you put 2 in the right position in comparison to -3 and 2/3. So 2 is going to be to the right. That's an equal sign, so we use a closed circle. And then greater than or equal to, shade to the right. Now, make sure you put an arrow. So remember, the solution to the compound inequality, that union, so it's an R statement, so it's a union, means that anything shaded here or any real number shaded here is a solution to the original. So you're going to merge the two into one graph. So the solution's 2. 3x plus 1 is less than -10, or 2x minus 5 is greater than or equal to -1 is, and then you're going to put the two together. So here's -3 and 2/3, open circle going to the left, and then here's 2, closed circle going to the right. Again, make sure the numbers are correct on the number line. So a negative number is to the right of a positive number. Now here's the graph. If you are asked to write this in interval notation, remember what to do. So you're going to go from left to right. So this is -infinity. It's pointing towards -infinity. So -infinity to -3 and 2/3 with parentheses because of the open circle. Union, and that's closed, will be bracket 2 and then 2 infinity. Now remember, infinity, -infinity always uses parentheses. So make sure you use parentheses here. All right. So that was number 5. Okay, let's look at number 6. So this would be number 6. All right, so number 6, we have 2x plus 5 is less than 9, and, so notice it's an and statement now. So remember, when you think of and statement, you think of intersection, all right? So, and 3x minus 1 is greater than or equal to -13. Now remember, the solutions to this compound inequality, whatever number is the solution, whatever real number is the solution, has to satisfy both of those, this one and this one as well. With an R statement, the solutions here has to satisfy either of those. Does not matter whether it's this one or this one. But with an and, it's got to satisfy both. It's got to satisfy both this one and this one. Okay? All right, so let's go ahead and rewrite this over and solve each one individually. And let's see what we get. Okay. All right, so I'm going to subtract 5 from both sides here. So I get 2x is less than 4. And dividing both sides by 2, I get x is less than 2. All right, so remember this is, x is less than 2. So any real number less than 2 is a solution to this. That's not necessarily a solution to this because of the and statement. But I do know that any real number less than 2 satisfies this. But the solution has satisfied both this and this. So that's why we have to look at this as well. So let's look at this. So I'm going to add 1 to both sides. So I get 3x is greater than or equal to negative 13 plus 1 is a negative 12. Dividing by 3 to get x by itself, I get x is greater than or equal to negative 4. Now remember, that's an and statement. So if I look at each one individually, all right, so here's 2. X is less than that, so open circle going to the right, just like this. Okay. Here is x is greater than or equal to negative 4, the graph. So negative 4, make sure you put in the correct relation with respect to 2. Closed circle, equal sign, and this time I'm going to the right. Now remember, this is an and statement. So the solution that satisfies both of those at the same time will be any real number that they have in common. So it's going to be from negative 4 to 2. All right? So you're going to write it out like this. You're going to say the solutions 2x plus 5 is less than 9, and 3x minus 1 is greater than or equal to negative 13 is, and then you're going to put on one graph, you're going to go from negative 4 to 2. Negative 4 closed circle, 2 with an open circle. So negative 4 to closed circle, open circle, and then shade in every real number between them. So there's the graph. So you found the solution. So the solution that's shaded, those, and there's an infinite number of solutions here, infinite number of real numbers that are being shaded. So any real number that's in here between negative 4 and 2, including negative 4 because of the closed circle, but not including 2 because of the open circle, is going to make both of those true at the same time. Now, if you want to write this in interval notation, remember you always go from left to right, from smallest to largest. So you can say bracket, because of the closed circle, negative 4, comma, to 2 with an open circle. So you use parentheses. All right, so that was number 6. All right, let's do one more. So this will be number 7. So number 7. All right, so there is that compound inequality that looks like this now. All right, so remember, you have a variable expression in the middle, and you have two inequality symbols in the same statement, like this. But remember, it's important you know this, that this, when it's written like this, that's an and statement, right? That's an and statement. All right, so when you split it apart, you would say 3. So it's kind of like covering this up right here. So you say 3 is less than or equal to 4x minus 9, and at the same time, 4x plus 9 has to be less than 11. That's what that's saying. That's what that means. Okay, so that is an and statement. And then you would solve each one individually and find the intersection. So remember, and means intersection. So let's go ahead and do that. Let's go ahead and do it like this. So let me go ahead and rewrite this over. So 3 is less than or equal to 4x minus 9. So I'm going to solve for x. I'm going to add 9 to both sides. 3 plus 9 is 12. It's less than or equal to, this is 0. Negative 9 plus 9 is 0. It's equal to 4x. To get x by itself, I'm going to divide both sides by 3. All right? By 4, excuse me, 4. And so 4 divided by 4 is 1. 12 divided by 4 is 3. That's what I meant. All right, so I get 3 is less than or equal to x. Now remember, 3 is less than or equal to x. 3 is less than or equal to x is a solution to this inequality here. Okay? But I'm looking for the solution that satisfy this original compound inequality. So remember, that's an and statement. Also remember that 3 is less than equal to x also means that x is greater than equal to 3. All right, so sometimes for students, it's easier to graph if x is to the on the left-hand side. All right, let's do this one. 4x minus 9 is less than 11. So I add 9 to both sides. I get, and combine like terms, this is 0. I get 4x is less than 11 plus 9 is 20. Divide both sides by 4 and reduce. 4 divided by 4 is 1. 1 times x is less than the 20 divided by 4 is 5. All right, remember that's an and statement. So the solution to this original compound statement here is any real number that's greater than or equal to 3 and at the same time less than 5. So let's look at each one individually. So here's x is greater than or equal to 3. So let's say this is 3 here, greater than or equal to 2, so it'll be closed circle because the equal sign going to the right. Now let's do 5, x is less than 5. On the number line, let's graph that. So 5 is going to be to the right of 3. So that'll be an open circle because there's no equal sign, and then it's going to the left. And remember, that's an and statement, right? That's an and statement. So I'm looking for any real number that they have in common. And that's going to be from 3 to 5. So you're going to say the solutions to 3, always rewrite the original problem. So 3 is less than equal to 4x minus 9 is less than 11 is, and then you're going to say 3 to 5. So 3, 5, close circle in 3, open circle in 5, and shade in every number between them. So there's the graph. If you're asked to write this in interval notation, you're going to go from left to right, from smallest to largest. You're going to say bracket because of closed circle, 3, comma, all the way to 5 with, now since that's an open circle, you're going to put parentheses. All right, now let's do, so that's your solution right here. So in any real number between 3 and 5, including 3 but not 5, is going to be a solution to this statement. So for example, do y'all agree that 4 is in here, right? And remember, there's an infinite number of real numbers. I'm just using an integer. But you have 3.4, you have 3.087, all those, so you have an infinite number of real numbers. You have the square root of, let's say, 17 that's in here. All right, so any real number, rational or irrational, is a solution. But if I pick 4, let's see why 4 is shaded. What's 4 times 4? 4 times 4 is 16. 16 minus 9 is 7, right? So is 3 less than or equal to 7? Yes. And is 7 less than 11? Yes. 7 is not shaded. So let's see why 7 is not a solution. What's 4 times 7? Well, that's 28. 28 minus 9 is 19. 3 is less than or equal to 19, but is 19 less than 11? The answer is no. Okay? All right, so only those that are shaded that you see here is going to be a solution to this original compound statement. Now I want to do this one just like we did before. So remember the way that I did this here was I wrote it as an and statement. But I want you to remember that you could have done this. 3 is less than or equal to 4x minus 9 is less than 11. So you could have, if you wanted to, gotten x in the middle without having to break it down as an and statement. So in other words, you could have done this. So let's go ahead and add 9 to all parts. And 3 plus 9 is 12. Is less than or equal to 4x. This is 0. Is less than 11 plus 9 is 20. Now you see that 12 and that 20? See that 12 and the 20, right? There's the 20. And there's 12 right here. 12, 20. All right, dividing both sides by 4. And notice you're almost done. 12 divided by 4 is 3. Is less than or equal to 4 divided by 4 is 1. 1 times x is x. Is less than 20 divided by 4 is 5. There's your solution. So the solution is any real number between 3 and 5. So if you graph it, it'll look like this. 3 with the bracket, with the closed circle because of the equal sign. 5 with an open circle because there's no equal sign, and shade in every number between them. And there's your solution, just like we had here. See that? Watch. You see right here. So So you need to know both, though. You need to understand that this statement, the way it's written, is really an and statement. So you have to know that. That's going to be important at some point. So you have to make the connection between this and this. Okay? All right. So that should help you with the with the topic on solving a compound linear inequality and then graphing solutions. So these are going to be and statements and also an or statement. Okay. All right. So that's going to be it. So that is the end of this lesson on solving a compound linear inequality.